Hi. So at this point for Unit 4, which is about atoms in the periodic table, we've learned a little bit about how the atoms, how the models of an atom came to be, a little bit about the history of the atom, including Rutherford's Rutherford's gold foil experiment and Thomson's plum pudding model, which you drew from the board. Got a little bit into what a proton, neutron, and electron is, the more current model of the atom, and what an orbital is, where the electrons live, what a valence electron is. All of this is review. We also took some time to how our periodic table looks and why it looks that way, why it's put together that way, what's a period, what's a group, and I talked about ions. But we have not got into how the structures of atoms differ, and so that's what this little short video will be about, is how the structure of the atoms can differ. So the atomic number of an atom is equal to the number of protons. And you can find that number on the periodic table in each box for each element. There's a big bold number, a whole number, and that number is the atomic number, the number of protons in the nucleus. But each element, let's just say sodium, for example, sodium can have lots of different, it always have 11 protons, but it can have a different number of neutrons, and those are called isotopes, which we'll get to in a second. But the mass number is if you add up the protons plus the neutrons. So mass number equals protons, which is the same as the thing as the atomic number, and added to the neutrons. If I gave you two of them, could you find the third? And the answer is you can, and you will. So I'm going to give you two of the three, and you find the third one. Now, the mass number, you don't know unless it's told to you, or I give you neutrons, and you can find protons, and then add those two things together. Each element, though, has its own unique number of isotopes. And isotopes, it's the same element, but it has different numbers of neutrons. So, for example, every atom of sodium, always, find sodium on the periodic table on the left-hand side there, you'll see that every element of sodium always has 11 protons, every atom. Okay. However, some of the atoms in sodium might have 10 neutrons, 11 neutrons, 12 neutrons. Scientists already know the exact number, but each of those different versions of sodium are called isotopes, and it's very common to have lots of different versions, and you can look them up, but you would never need to do that for this class. But you could go online and find them without a problem. But everyone already knows all the isotopes of sodium, but each atom of sodium is different. If you were holding a giant chunk of sodium in your hand, there would be dozens of different isotopes of sodium, and they're all still sodium, just that each of them has may have a different number of neutrons, and because of that it weighs a little bit differently. But still, it has the exact same chemical and physical properties, aside from that small mass difference. So like I said, if you knew the mass number and the atomic number, you can calculate the number of neutrons. It has very easy. So here's what that looks like. Got uranium-235. The 235 written right there after the uranium, that is the mass number. Okay, so they'll often write things like that, and you'll see that in the later part of this video, where this part after that the name is called the mass number. So you want to find the number of neutrons or number of protons in uranium, you look at the periodic table. But if you want to have an isotope with a different mass number, they'd be told to you like this. That's what the 235 is there. So it always is given to you, or you have enough information to find it yourself. So like all uranium atoms, every uranium has 92 protons. Okay, and if you wanted to calculate neutrons here, you know that the mass number is 235. You know the atomic number is 92. They get that from the periodic table, and you simply subtract them to find the number of neutrons. And each element will have each atom of uranium may have a different number of neutrons, and so they're going to have different mass numbers, but they're all still uranium. And you can look up for any element what those are, and scientists already know them. But like if you're holding a penny, for example, penny is copper. If you take a look at your periodic table, right in the middle you'll find copper. It's element number 29. And so every single atom of copper in that penny, trillions and trillions and trillions of atoms in that penny, all of them have 29 protons. But some of them might have 30 neutrons instead of 29. Some of them might have 28 neutrons instead of 29. So you can look up what the exact number is online, but not really important for this class. But those are isotopes. They're all the same element, just different numbers of neutrons. And in a minute, we're going to look to see how to do some of those simple calculations on how to write out numbers like this for the uranium-235. How do you write that out, and how do you do some calculations with that? this document where you've got an isotope listed here and you want to answer some questions about it, you can do all of that with just the information that I've circled there, but also with your periodic table. Okay, so this gives you enough information along with the periodic table to answer all these questions that are up here on the top part of this table. So we're going to go through kind of the table and say what is what and where you need to find this information. You either get it from the words right here or you get it from the periodic table itself. So first is period and group. The period is the row that the element is in, and the group is the column that it's in. Okay. Average atomic mass on the periodic table, that's the number below the word on the periodic table. So if we're looking at like calcium 44, so I would look to the bottom of calcium where it says it is atomic, or it says its name, and right below its name you'll find that there's a number there. The number is 40.078, so I'd write 40.078. Again, that number is right below the word calcium on the periodic table. So we're going to use a periodic table to find average atomic mass. PT stands for periodic table. Now, atomic number, that also comes from the periodic table as well. Okay, the atomic number is the number in the upper left-hand corner for the element. So if we're looking again at calcium, again, I know it's calcium because it says right there, the number is 20 protons for calcium, or atomic number is 20. Now the mass number, here's where I start to use what's written for me. The mass number is actually right here. So all of these, those are the mass numbers for each of the things. So in this case, it's calcium 44, and so the mass number is 44. Now the protons and the atomic number, that means the same thing. So these two are joined. They will be the same number every time. Okay, so protons and atomic number, that's the same thing. Now, if you want to find neutrons, if you're just going working left from right, the neutrons is the mass number. Neutrons equals mass number minus atomic number. Mass or minus atomic number, okay? So that's going to go right there, okay? You're just reading this from the page. So atomic number is this one, mass number is that one, and neutrons equals mass number minus atomic number. So in this case, we're going to take 44 minus 20. Actually, I'm going to squeeze it in there. Check this out. They don't teach you this. 44 minus 20. And so our mass number in this problem, of course, is 24, okay? Can I make the equal sign? Oh my gosh, crushed it. Electrons, for this particular worksheet, when you're doing this, it'll be different when you take chemistry, but for this worksheet, the protons is also equal to the electrons. So those three are all going to say the same thing every time. Okay. Now, metal on the, or non-metal on the periodic table, it's just the left side or the right side. The metal is the left side, and the non-metal is the right side. So I'm going to write left right there. I'm going to write right there so we don't forget. Okay. That gives you all that you need to fill in this information. So calcium's way on the left side, so it is a metal. Okay, the period for calcium, that's the row it's in the fourth period, and it's in the second group or column. Okay, so that's how I would have all of that one. Okay, I'm gonna do one more and then you're gonna try the rest, but this is where you get everything and how it all works together. And so we're gonna do lead 172. So we start by finding lead in the periodic table, and lead is way down the lower right-hand side, it's PB. And it's in the 6th period, 6 rows down, and it's all the way over in group 14, okay? And the groups are labeled across the top there. You can see they're labeled 1 through 18. There's 18 columns or groups in the periodic table. The atomic number, or average atomic mass for lead is 207.2. The atomic number for lead, again, find this all in the periodic table. This is all periodic table stuff. That's what PT stands for there. The atomic number is 82. And the mass number, okay, now here's where we need this. The mass number is 172. So we write 172 there. Protons, again, the same as the electrons. You just go ahead and fill them in right now. 82, 82. They're all the same, and that's why I've joined them up here. So you can see that they're all the same. And then to find neutrons, we're going to take 172 minus 82. I think I got my trusty calculator. 172 minus 82. Everyone knows that is 90. So that's going to be 90. No, come on now. 90 neutrons. If I said protons before, I'm sorry, it's neutrons. And then lead is actually, there's a stair-step line in the periodic table. You'll have it colored in, but lead is still considered underneath that stair-step line, the left side of the periodic table, even though it's kind of on the right side. It's the stair-step line that separates it. So everything underneath or to the left of the stair-step line, that's a metal. And everything to the right of the stair-step line, the upper right-hand corner of the periodic table, that's a non-metal. So lead is a metal. A lot of these you might know. Okay? Your job is to fill in the remainder right here with all the information that you've got. Okay? You can work together if you need to. And that kind of gives you an idea of how to fill in isotope tables, how to get all the information about an atom from its isotope name, symbol, and also the periodic table. This has been super fun. We'll see you soon. Bye.